Good morning, everyone. Welcome to the second green session. Just a couple pieces of administrivia before we get started. First off, if you bought any +1 tickets, they can be picked up at registration between now and the start of the last session. There are still a few available out on the Eventbrite site. So if you need one, you can go there and purchase them. But once they're sold out, they're sold out. And then I'd like to introduce Jimmy Balmert, who will be your speaker.
Thank you. Okay. All right, there we go. All right, so always be delivering. One of the bigger things I get interrupted for is slides. These are all available up here on GitHub. I'll show this again at the end of the presentation. So I'm Jimmy Balmert. I'm from Manifest, been in the industry for about 20 years. Big fan of craftsmanship and just trying to improve coding practices. Robert Cochran has also been a big contributor to this presentation. We originally created this as a workshop for CodeMesh. So if you see him around, tell him thank you. So what we're going to talk about today, we've got this idea of continuous delivery and deployment and using pipelines. And we're going to step through what are the benefits for that. And then we're going to step through a whole bunch of scenarios through the eyes of a tech lead and his team in building up a pipeline from start to finish. So we've got these two terms, continuous delivery, continuous deployment. And sometimes they're used interchangeably, but they're subtly different. So with continuous delivery, this implies you check in your code to some repository. Some process starts checking that out and building it and running tests and doing all of the due diligence against it. And then at the very end, there's a human decision on do we deploy this out to production. In continuous deployment, go through the same thing. We check in our code, go through that same kind of rigorous process, and we just automatically ship it to production. So let's talk about what a pipeline is. A pipeline is just a series of steps connected one after the other, with the caveat that we can have parallel steps that move your build process one after another through from start to finish. So we'll have something where we check in our code like we were talking about, and we'll just keep executing steps one after the other. And when we're done, push it out to prod. There's a few tools out there for that. I mean, there's Concourse, there's Jenkins. I think even Travis CI can do it. We're going to be focusing on Jenkins today. So what are the benefits to this continuous delivery? Well, let's look at the standard development timeline. You have time spent developing a feature. We have some time where your customers are using that feature. It's in production. There's the great in-between, waiting. I'll try to speak up. All right, so developing features, waiting, and then customers get to use them, right? So when development's complete, it just sits there. When we're done waiting, when we've hit our cycle where it's even if it's a sprint of 2 weeks, a month, quarterly, we finally push it to production. In a continuous delivery timeline, we cut out that waiting period. Right? So that waiting time just disappears, and we can get to market faster. Now let's look at it from the other perspective. Eventually, no matter what you do, no matter how much due diligence you put in, a bug's going to slip into production, right? I've done it, sorry. It happens to everyone, right? Now look how long you can have between the time you wrote that feature and the time you detect that bug, right? So let's look at a timeline here. If it's been 1 day since you deployed it and someone found a bug, you're going to feel okay about it. Not a lot has changed, and you probably have a good idea of where to look. You've probably boxed it in already in your head. Hey, I only changed this little bit of code over here and check that in. That's probably where the error is. Now, if it's been a week, you're still probably okay, right? You may have worked on a few other things, but it's still relatively fresh in your mind. Been a month, you might start to panic a little. Got to really remember, what the heck were you doing, right? If it's been a year, well, you're fine because someone else is going to take care of it. You've long since rolled on, right? Right, so what I'm saying here is the longer that gap is, the more stress you're going to have when you do hit that bug. The smaller that gap is, the more confidence you're going to have that you can handle that bug. So we'll have greater confidence and less stress. So I want to look at two sets of instructions here. This is origami. So we got one here, one here. If you can't tell what that is, it's an adorable lion. All right, and now I'm going to tell you, all right, I need you to go ahead and put this into production perfectly first try. Which one would you opt for, right? I hope we can all agree this one would be the easier one to try. Smaller changes imply less risk. So if we just take a small change we've just checked in, run it through our pipeline, and push it through to production, that is much less risk than if we accumulate 2 weeks worth of changes and push them to production. So now let's look at branching strategies. So this is one where master represents what's in production. We've got various tags there, and we've got a developer branch that sits on top of it. And this is where the developers will branch off and push all their changes into. And then when we've deemed it's ready to go to production, we'll push it there and then tag it and push it back to the official master branch. So it's always pristine. All right, so we'll have feature branch there, feature branch here. Well, we can look at a different mode where master equals the latest branch. Right, it looks pretty much the same, except for we take out this whole master equals prod part. Just shift things up a little. And master is that development branch. And when we're ready to push to production, we cut off a release branch and we push from there. Now what happens when we're in a continuous deployment world? We can simplify all this. We can have master, which just represents the latest changes, and we branch features off of that, and we just keep resyncing or rebasing from master. And when we're done, we push it back to master. And this should look kind of familiar to you, because this is generally what you see in these other forms of branching when you are, when stuff hits the fan and you're trying to do a hotfix, right? Let's just stay in hotfix mode the entire time. It's that much easier. So it can, if you want, be a simpler branching strategy. All right. So that's why we want continuous delivery. We get a bunch of benefits from it. Why do we want a pipeline? Well, in Jenkins, you can have a couple different views, and you can see all the steps from start to finish for your entire pipeline. You're not just seeing, hey, how long did it take for me to, compile this? How long did it take me to test it? You get to see everything. You get visibility of your process. So I'll throw up a few names here. You may have heard of a few of these. Why am I throwing these things up? These are all places that are using continuous delivery and deployment right now. This isn't theoretical stuff. Some real big boys out there are driving this out and doing this. And it's a real competitive advantage for them. This is going to become the norm. So might want to, dive in and see what you can do with this. All right, so I said we're going to step through a bunch of scenarios following a team. So let's go ahead and meet that team. So we've got Sam, our tech lead, brand new to the team, just been brought in. Sam's a nice guy, likes to ask questions, lots of questions. You may know the type. We've got Diane, she's our developer. We've got Quinn, our QA lead. We've got Todd, our tech ops guy. So Sam starts automating the build. So the first thing Sam does when he gets to this team is he wants to know, what is our build process? And of course, Diane's there to help and to say, well, when we use Jenkins, we'll start the build after we commit the code. We'll create a standalone jar. And we will push it to QA. At which point Quinn takes over and says, yeah, we test it and approve it or reject it. And eventually, at some point, we decide to deploy. Sam thinks about this for a second. So why can't we just set it up to automatically start building after we commit? Why do we have to do that as a manual process? So let's start our first pipeline. Just create a new item, give it a name, select the pipeline type. It's pretty simple. Towards the bottom, you'll have this drop-down box, and there's two modes of doing pipelines. You can literally have a huge dialog box or text box and do it all inline in the job itself, or you can externalize it to your source control system. Externalizing it to your source control system is the preferred mode, because you can actually put this all in source control. You never lose these. You can start doing some really interesting things with these once you've got them in source control. So to do that, we're going to tell it, get your pipeline script from source control management. Doesn't really matter where it's coming from. In this case, I'm just selecting Git. And if you see that little box at the bottom, that's supposed to show you the root of your project. Just put a file named Jenkins file. Capital J, everything else, lowercase, all one word. So what does a pipeline actually look like? Well, it's just a script. It's actually a groovy DSL, but it's just a script. And it starts with pipeline with some brackets. Pretty simple. And we have this agent any. This says I can run it anywhere. Not a real big deal. I mean, technically, I think we should probably limit this one to Linux because it's going to use some shell commands, or a Macintosh, or anything but Windows. But you can set this to what anything you like. It can have any of the major modifiers, and if you've got various different sizes of worker nodes for Jenkins, you can control it here. Then we have tools. Well, we're going to be using Maven. It also has native support for Gradle. You just have to tell it, I've set up Maven in my configurations inside Jenkins, and here's its name, and it's just there. The rest of the script is stages, and those are going to represent each of your individual steps. So from now on, everything's just going to fall inside that stages block. Just assume the rest of that is here. And we're just going to put new stages in there one by one. So let's create our first stage. Build. Pretty straightforward. We have to put a steps block in here. Technically, you can support multiple steps block. I'm not sure why you do that, but it does allow it. But you have to have at least one. From there, we can run a shell script, or an inline shell script. And we can just say, let's run Maven -B, meaning batch mode. I don't want to have any prompts come up to me. Clean and package. And the infamous skip tests. All right, so that's all it takes to get started of just building a jar in Jenkins. So let's move on. So it's the middle of the night. Sam gets a phone call. Hello. Tech ops guy. He's a little bit worried. He's a little anxious. Our application isn't responding. Thankfully, Diane's there. She's like, oh, I know what's going on. I think we accidentally deployed the wrong version. Oops. I'll go ahead and put the correct one out there now. Oh, good. It's working. And our tech ops guy is happy. That seems like a problem to us. How did we get a bad artifact up there? How can we know that we're going to be deploying the correct thing to production? Well, we can start adding versions to the artifacts. And we can start adding tags in source control and make sure those match up. So we have our build stage. We've seen this, and we're going to change it up a little bit. I'm calling off to this other shell script. And if you notice, I can call off to anything I want. And we'll show you the contents of that shell script in just a few minutes. But you can actually start externalizing part of your script so that your script just mentions the big details and the larger points, and the details are pushed down into smaller components. So you can actually decompose and make reusable pieces out of these scripts. So I've got two scripts I'm calling here: update git for push and increment palm version. Then do what we were just doing before. And those scripts, I'm going to put them in a CI directory for continuous integration within the same project. If these become useful enough, you can promote them up and make a common project for all of these. It's just a simple bash script, and I'm checking out master, and I'm saying reset, and then git pull. So I'm doing a lot of weird git commands to try to reset the archive. Why am I doing this? Jenkins. Jenkins likes to take shortcuts to make things faster. So when you said, hey, pull down my code and go do a build, it will actually go pull down a read-only view of that, if you will. It'll get just enough information to compile your code. Now, if we're trying to update something like, say, a version number in a POM, we need the full copy. This will restore it really quickly. So increment the POM version. I'll go ahead and apologize for this in advance, and it's all Maven's fault. Maven-B, build helper, parse version. All that says is, go parse the current version of this script, or of this POM file. And we want to do a version set. We want to change the version. And we want to say our new version equals the parse version, major version, and minor version, and next incremental version. And all this does is say, increment our minor version by 1 by reading in the information from the current version. And then commit it. All that says is, you made a backup copy when you started doing this. We don't need it. Throw that away. I will never show that to you again because it's ugly. But the general idea is that we're incrementing our version of our artifact before we start doing the rest of the build. Now, we're not going to commit it yet. We're just going to update it in flight. And if we like everything, we'll commit it later. So for tagging, we'll do that commit we're talking about. And then we'll create a tag. Committing's pretty simple. Just add our change and commit it with a message. Most systems that do this kind of continuous integration will honor some sort of special message at the beginning of a commit message, like this skip CI. Jenkins is not reliable in doing that, unfortunately. And then we just push it back. And then tagging, get the next version, which is this ugly script here. All this is doing is parsing that POM file to get the version out and using that as our tag. Again, a simple message on there and push it up. So with that, we're getting a little control around our versions. We'll know which artifacts we're building, what we're handing off, and we'll always be able to tie it back to source control. So if something happens and our jar is corrupted, we lose something, we can go build it again from source control and know that we're going to have the exact same copy. So we have a conversation with our QA lead. And she says, hey, it's good that we're tagging these things and we're versioning them, but we still have to prove that we're putting the right artifact into production. Why do we need to do that? When your company is big enough, you're going to have some sort of auditing. You're going to need to prove a paper trail that says, yep, I built this from here, put it over here, and it went into here, and nobody got it in between and did something bad to it. One of the easiest ways is just to automatically push this up to Nexus so you have one central repository and use that for deployments later. So we're going to push that to Nexus. And this is super tricky. We'll create a new stage, put our steps, and we're going to say deploy. Maven's built to do this. They built Nexus. They built the repositories. Now, in your POM XML, you'll have to have a little configuration information telling it which repository you're going to and credentials and things like that. But that's all hidden away. All right, it's nighttime again. Sam's been called one more time. And once again, hello. Uh-oh. Our tech ops guy again. Todd, what's going on? The application's not responding again. Well, we know we pushed the right artifact up. Luckily, Diane's there to save the day one more time. All right, all done. Back. The app is back up. I pushed in a fix. Whew. All right, everything's back to normal. We can go to bed. So what happened? Sam's kind of curious about this. He's a guy that asks questions. So how do we reduce the risk of bugs like that just going straight to production? I thought we tested this stuff, right? Well, we have unit tests. Some of them are broken, though. We run them locally, but we ignore the failures. I won't shame anyone into admitting that they have been there, but I'll say I've been in the group that's done that and didn't see anything wrong with it. We're going to try to move out of that mode. So this is one of the caveats to trying to move towards continuous delivery and deployment. You have to learn to trust your test suite. If you've got a terrible test suite, you're going to have to put a lot of time into trying to correct that before this is a viable option. For some code bases, that just may not be an option. So Sam says, well, let's start reconditioning our tests. Let's remove the broken ones or fix them. Let's opt to fix if we can. Or if they're just not providing value, let's get rid of them. No point in having a long-running broken test that doesn't actually help you. And then let's start running those tests as part of our build. So for us to have a valid artifact, we're going to have to pass all our tests. So Sam's been around the block a few times, and he decides to have a one-off conversation with Quinn. And he knows that unit tests and integration tests that we may have in our code base are not going to be enough to prove that the app is working. We have to make sure the app is working when all the pieces are put together. So we asked, hey, can we pair up with you and start automating from end to end some of our critical features? And QA is all over this. They're like, absolutely, let's go. That's what we're here for. Let's build up some nice tests. We'll just do it methodically, just do one per sprint, not going to affect our delivery schedules. But we'll work together and we'll make it happen. So we have our build stage and we have our tag stage, if you remember. And in between there, we're going to place this testing stage. So we've got our steps. Maven B test and Maven B failsafe integration test. This is just arbitrary partitioning of the tests. In most systems, Maven test would be more than enough. But this will execute all your tests, and if anything fails, it'll abort the whole build. So we're guaranteeing we're putting some quality measures in place before we go live, or before we even hand it off to QA to play with. So this is when we're starting to mature our process a little bit. So adding health checks. All right, so Sam's been pondering things for a moment, and something's not sitting right with him. And he finally puts his finger on it, and he starts asking our Todd, the tech ops guy, hey, who detected the outages that we had the last few nights? Customers! Crap. That's not good. The last person you ever want to detect issues with your sites is your customers. So how can we get out in front of that? How can we detect those issues proactively before our customers? Well, you're never going to detect all of them, but you can detect a lot of them before they get to it. And we're going to add health checks. Now, that's a fairly broad term. Can mean a lot of different things to a lot of different people. But in general, it's literally just any kind of monitoring you put in place that can automatically tell you when something is in a bad state. In our case, we're going to use it to detect if a build has been deployed correctly. So that we don't accidentally think we're done with our job and leave production down and nothing's going through because we had a failed deployment. So to deploy for test. Hey, I'm cheating. I'm using a shell script. We'll look at it shortly. But this is pretty simple. It's just trying to say, let's deploy our jar to this test environment and use this port. It can be whatever you want it to be. This is just what we've chosen. So didn't I just say we're going to do health checks, though? Well, we're going to bake those into our deploy script, so you can't do it without. And while that hurts my eyes, this is really just a really complex way to get the current directory that your script is in, so that if I want to, I can call other scripts relative to where this script lives. And as we said, we're sending in the target, which is where do we want to deploy it and what port. And hey, look, I'm leveraging another script. Simple shutdown. This can be for whatever your system requires. And then start up. And then the important part, let's check to make sure it came up. Just a simple loop. Go to sleep. This is not an enterprise quality script here. Yes, this would loop forever if we miss, but we would at least detect that it's taking a while to deploy. Okay. So those acceptance tests. Sam's looking back at some of the failures they've had, especially that last one where we had a bug that got through, right? And we already put in our integration and unit tests, and we've got those running. But he took a closer look. And it's like, so what did you find out? Well, the unit test and the integration test actually wouldn't have been enough to catch it. It wasn't actually just the code, it was how it was integrating with other pieces that broke. The error laid in between. So let's start running our acceptance tests along with our unit tests. That way we can see how does the app respond when we put all the pieces together. And more importantly, let's make sure we've got test scenarios that cover our most critical features. We're not going to test everything at an end-to-end level because it'll just take too long. And we've already tested most of that at the unit and integration level. We have to trust those tests. So he says, thanks QA. Thanks for building all those acceptance tests so we can actually do this. No problem. Let's see what they do. So we'll put in another stage. Run the acceptance tests. So the acceptance tests are commonly stored in a separate project because they're usually written in a different language, Ruby, Jeb, with Groovy. So we'll go check that out. Move into that directory and do an install of our app. And let's see what the checkout does. Pretty simple. Hey, if it's not already checked out, go ahead and clone it for me. Nothing big. And then put it there. And then move into it. Then pull to make sure that we've got the latest changes there. Okay, so let's take a second to talk about QA for just a moment. So we've done something pretty significant here. We've put these acceptance tests in flight. And let's look at what our process really is right now. Our developer writes some code, pushes it into source control. Jenkins picks it up, runs our pipeline, builds a jar, and we've been handing that off to QA. And then eventually it goes to production. Well, what have we just changed by putting those acceptance tests in there? We don't need to hand off to QA now if we've done our job correctly. And that's a dangerous statement to make out loud, isn't it? You don't really ever want to say we don't need QA because that's really not the truth. And if we handle it this way and just assume we're cutting QA out of the loop, we risk losing an ally. So there's some politics involved in changing these processes. Like I said, the problem isn't that we don't need QA. The problem is we have them at the wrong part of the process. We don't want them at the end. We want them up front, pairing with us, giving all their sage advice, telling us, hey, look out for this scenario. Hey, have you covered all these things? We want that input from the beginning so we can bake it in from the start. Not wait until after we built everything and then they come back and tell us we messed it up. We can actually go faster if we bring them into the fold and go and have those conversations from the beginning. And then they don't have to do that part at the end of doing all that manual testing. So if they're consulting with you and they're not spending all their time manual testing, they can do something even more valuable. Exploratory testing. And this is an extremely valuable thing. We want to give QA free reign on their own instance of a server somewhere with our app to say, go break it, and come back with defects. Because if they can play and find out ways to get through your system, your users can. We want to get those defects that we're not going to capture just by writing our unit tests and understanding where we're just have too myopic a view of what we're building to really see all the little edge cases that could pop up. And our end-to-end tests are only covering a small segment of the scenarios. So by giving someone free rein to go and try to destroy your app, you can start closing some of those gaps. And depending on severity, it can be a drop everything, fix this huge gaping hole in our security. Or it can be, oh, that's minor, just put it into our backlog and we'll get to it when we get to it. Someone will prioritize it and we'll do it. But we can get incredible feedback that way and really improve the overall quality of your app. So now let's talk a little more about some advanced concepts that can really help you with using a pipeline. So one of the things that I've seen with teams is that the stories tend to be large. You know, we're new to Agile. We're in this Agile environment. We've been told to build these story cards. Now I'm going to go pick this card up and take 2 weeks and build it. That doesn't seem quite right. And some of the pushback you'll get is, well, I mean, this is the minimum viable feature I can hand out there. I can't push out a partial product. I can't break it down smaller than this. Or can I? Let's challenge that assumption. So how do you deploy partial features? We're going to use feature flags. And when it comes down to it, it really is just like an if block wrapped around some code. There's more advanced implementations that can help you, but it can be as simple as that, just a flag to say whether or not a feature is active when you deploy it. And so you can see here I've got 7 features, 6 of them active. I should be able to just toggle them and do whatever I want. And some of those features just turn off. So what does that buy us? Well, I can build a thin slice part of the end feature that I want, or something that goes end to end and actually builds up an approximation of the end feature. Doesn't have all the bells and whistles. I wouldn't really want to give it out to my customers because they're not going to know what to do with it yet. But I can keep building and iterating over it and pushing in small pieces and just keep going until the feature's complete, and then flip the flag. So what does this buy us? We can have much smaller chunks of code to work on, much smaller tasks. We can build up a better cadence, a better flow. Plus, if something goes wrong, I can turn it off. So, parallel tests. All right, so Sam's doing more analysis. He's doing his job. The builds are slowing down. Well, we keep adding integration and acceptance tests. We need to. And say, yeah, I know, I looked at them. They're all good. There's nothing there that shouldn't be there. Yet we're slowing down. This happens in real systems. It's best to get out in front of it. So what can we do to try to make those run faster? Well, the real answer is for the individual tests, there usually isn't much you can do. I mean, you can go and try to optimize them, see if you've done something in a inefficient manner. Usually the answer is no, you haven't. Instead, why don't we just break up the tests into groups, partition them, and then run them in parallel? Fortunately, the Jenkins pipelines support this. So if you remember, we already had our testing task, and we were doing unit tests, integration tests, and acceptance tests one after another. we're going to add in a little built-in function here called parallel. And it's going to take in any number of these blocks of code with a name. So we're going to have one for unit tests, one for integration tests, and one for acceptance tests. And this should look familiar. This is pretty much the same test block that we had before, only I've just broken it up and put it into different blocks within the parallel function. And this will actually try to run all of these at the same time and block until all three are done before moving on to the next step. Now, this is not necessarily an intelligent way to partition this. Your unit tests will finish in like 2 seconds, integration tests in 10, and your acceptance tests half hour. Have I really done anything with this? No. This is just an example to show how to use it. In a real world scenario, I would most likely partition my acceptance test before I did anything to the other tests and get those to run in parallel. Potentially even using an outside system to help with that, like Sauce Labs or some grid for running Selenium. So let's get back to those feature toggles again. So we saw how we can use those potentially to make our builds or to make our individual tasks smaller and can control completely when they go live. Well, they can be used for other things, right? So Quinn and Diane are sort of arguing over how to build a feature. Now, it's a pretty small feature, but they have two different ideas of how they want to approach it. And they can't figure out which one they want to do. And of course, they ask you, or Sam here. And Sam's like, no, I'm not supposed to decide that. Tell you what, why don't we just build both? Now, you can't do this with humongous features unless you've got a huge budget. But if this is something small, and you've been breaking your pieces down, your cards down into small chunks that are bite-sized, you can get away with this. And we'll use a feature flag to be able to swap the implementations. Okay, so that's the mechanics of how to do it. But how do we know which feature to keep? Well, we'll gather metrics. Maybe one has a better pass-through rate. Maybe people find one of the features better and actually are buying more because of it. We can measure those things. So now the big part. So Sam's been looking around and noticing how his team is doing. And he sees, all right, code coverage is going up. We're writing our tests. We're doing what we're supposed to do. Code complexity is trending downwards. We've been measuring it. We've been paying attention to what our tests are saying and actually refactoring and making the code simpler. And most importantly, we haven't broken anything by going to production in a long time. We've built up a track record. So it says, hey, team has really stepped up. We're ready. For what? Continuous deployment. We're already at continuous delivery. We're doing everything we need to do to find out if the artifact is ready to go. It's just a human decision right now on whether or not it goes live or gets pushed up to the production environment. But let's be cautious here. This is a dangerous move. If you aren't out in front of the politics that surround this kind of move, you're going to lose. It's not as simple as just your team making that decision. There can be a lot of emotions attached to telling a business person, yeah, we know that in the past we've been having a person be the gateway to, the gatekeeper on pushing this out to production, but now we're just going to let a machine do it. To them, this is what you're telling them. Huh? No. There's a lot of emotion that can be surrounding that. We have to get out in front and explain to them they should still be in control. Business is still going to control all of this. But how? Well, we are going to deploy our changes as soon as they've passed all the quality checks. But we're using feature flags. You can decide when and if any of those features actually goes live. So I control all the features like I used to? Right, exactly. If you can sell it this way, you can win. If you just come out and tell them, hey, we're just going to, every time we finish a build, we're pushing it to production, you're going to cause a panic. You need that track record, and you need to explain to them, business still has control. We are here to serve their needs. And by doing continuous deployments, we're going to do it better and faster. So deploying to production. Well, that deployment script we have should work. It's just a different environment, maybe a couple environments, and we'll just tell it, hey, deploy. There's no big thing to it. This is just the last step that runs. And with this, we've achieved end-to-end. Someone checks it in, and it goes all the way to production. Now, there can be plenty of other stages you can throw in there. And we're actually going to talk a little more about how we can make this cleaner. You can throw in things like sonar, gather metrics, other quality checks, anything your particular process needs. So let's talk about BlueGreen, because this is the last critical piece that you're going to need to be able to seamlessly push to production with high quality code if you've been able to achieve everything else in this presentation. So your business partner comes to you and says, every time we go down, even for a few minutes, we're losing $10,000 to $100,000 in revenue. All right, this is an outlandish use case, but stick with me. It's like, oh, wow, I had no idea. Let me talk to my team. So anytime we go down, even if it's planned, yes. Even on weekends? Yep. Huh. So what do? We need to prevent downtime during our deployments. But how? BlueGreen. It's a pretty simple concept. It assumes you have some sort of router in front of your production servers or wherever you're using them. And it assumes that you're pointing to one environment. We'll call it blue. And you've got a backup environment that you can flip over to that has the same code. And it can seamlessly move traffic. Now there's some implications here. If you've got state on one of your machines, you're tracking sessions, anything of that nature, you're going to have to find a solution to replicate between the two. But if you're not, we can just deploy the upgraded version to the green environment because it's not currently taking traffic, and then switch traffic over to it. And then it's pretty simple. We'll do the same on the blue side. Switch back. Now we've upgraded, and no one saw the website go down. So how do we do that with a deployment script, our deployment job? Well, you would have to have something that can move the traffic, and that's usually outside the scope of these simple things. So it can depend. It can be an Nginx configuration. It can literally be telling a Cisco router to move something by a script. There's many different options. But we're saying, hey, let's move to the green environment and deploy there, then move back, and then resume traffic to both if we want. We can do whatever configurations we like so long as we can take one out and rebuild it or redeploy to it with it not taking traffic. Now there are other ways to do the same kind of thing instead of BlueGreen. You can do rolling deployments if you've got enough instances. Like if you've got management by Kubernetes or something like that, where you can literally just tell it to go roll out this new version, and it'll just stand up a new server, shut down one of the old ones, stand up a new one, shut down one of the old ones, and just keep rolling in new ones for you. You can do very complex things. This is just a basic idea of it. But with this, it's safe to deploy as many times as you want. Many times as you want, you can deploy per day, as long as you've got new changes coming in. And if your company's large enough, you've probably got 10, 20, hundreds of changes coming in per day. There's nothing stopping you from deploying all the time. We can keep adding features and value very quickly. So here's our bonus stage. So we do have a valid pipeline there, but we've got one flaw that Jenkins, combined with a few other tools, forced us into. Our problem is Jenkins plus Maven plus trying to update a version creates an infinite loop. So I'm checking the code for a change. Oh, a new change came in. Let me go build it. Okay, I'm going to update the version and commit a change. Okay, I'm going to go check for a change. Oh, hey, look, there's a change. I'm going to check that out, build it, and change the version and commit that. So on and so on. Now, most systems have the ability to say if you put if you have a certain user or a special tag in the message, that it will ignore that and assume that's not a commit that it needs to act on. Jenkins is supposed to do that, but to my knowledge, it still has problems and it can't accurately detect that. But we can put something in place to fix that really quickly. So let's just put a task in front of our pipeline and not have our pipeline actually pull SCM anymore. We'll just have another job that does that for us. So we'll have it monitor the repository we're interested in. Put in a schedule that says, let's check like every 5 minutes. Whatever is reasonable. Whatever GitHub will put up with, you know. And then we'll just execute a command to do something a little crazy here. And all it's doing here is saying, if the last check-in, if the last commit to the repository was done by the user Jenkins, abort. With a nice little message saying, there's no need to run this. Otherwise, go fire off our pipeline. And so what happens with this? Well, your pipeline will stay green. It'll only fire off when there's real problems or when there's real code checked in. This job will probably light up like a Christmas tree, green, red, green, red, green, red, green, red. So just hide this one away. So real quickly, our benefits of doing continuous delivery with a pipeline: we can get to market faster, we'll have greater confidence, lower stress when we hit issues, we'll have lower risk from making our smaller changes, we can have simpler branching, and we can have visibility of our entire process. And let's watch for, when we're trying to move into this, we don't want to alienate any of our allies. We want to watch out for emotional responses to changes in our process. And we need to make sure that at every point we're aligned with the needs of the stakeholders. That we're giving them control and that we're delivering value for them faster. So I want to thank you for letting me talk here today too. The slides are here. You can reach me at Tremble, or you can on the Green channel. So thank you, everyone. No questions? All right, no questions. Anyone in the room? Okay.